Hey class, hi, hello, namaste, adab, sat sri akal, assalamu alaikum, vanakkam and khamma ghani to all of you. Welcome to today's class and this is your CBSE ninth in one shot. The topic for today is quadrilaterals, right? So we will be discussing the topic quadrilateral in one shot video. So we'll be doing the whole revision and then we will be solving some questions. Okay, so let's start the class. But before I start the class, I would like to request you all to share the video among all your friends so that maximum students can join the session and all of us can learn at one time. Okay, so do share the session and subscribe to the channel if you are new over here. So first thing first, the quadrilateral, if we learn, so what is a quadrilateral? So quadrilateral is a polygon with four sides. Okay, remember four sides hote hain, there are four angles and four vertices. Vertices means these corners. So four vertices A, B, C, D, four sides A, B, B, C, C, D, A, D, and four angles, angle A, angle B, angle C, and angle D. Okay. Then the one important property, angle sum property for a quadrilateral. So we can say that sum of all the four angles of a quadrilateral, for any quadrilateral, sum of four angles for any quadrilateral is equal to 360 degrees. Okay. The proof is very easy. This is your angle D, this is your angle B. Angle A I can divide in two parts, angle 1 and angle 2. Angle C I can divide in two parts, angle 3 and angle 4. So if you use angle sum property, so you can say angle 1 plus angle D plus angle 3 is equal to 180 degree. And then I can say angle 2 plus angle B plus angle 4 is equal to 180 degree. Add both the equation, angle 1 plus angle 2 is angle A plus angle B. Angle 3 plus angle 4 is angle C plus angle D is 180 plus 180, 360 degrees. Got it? This is how you can get the proof for the angle sum property. Very easy proof. Got it? So this is the first property, very important one. Next thing, types of quadrilaterals. So there are some special quadrilaterals which we will be learning in this topic. So that is trapezium. Remember, the definitions of all these quadrilaterals is very important for our understanding. So definition for a trapezium is a trapezium is a quadrilateral in which one pair of opposite sides are parallel. Any trapezium in which any quadrilateral in which if one pair of opposite sides are parallel, it will be called a trapezium. Okay, kite is in which two adjacent sides are equal. Two pair of adjacent sides are equal. So this and this is equal, this and this is equal. Parallelogram is both the pair of opposite sides are parallel. Both the pair of opposite sides are parallel. So you can clearly see in a parallelogram, one pair of opposite sides is also parallel. So parallelogram comes under trapezium as well. So if we talk about quadrilaterals, one branch goes for trapezium in which one pair of opposite sides are parallel. One branch goes for kite. Under trapezium, we can also say parallelogram also is a trapezium, because in a parallelogram we do have one pair of parallel sides. Okay, in parallelogram we do have one pair of opposite sides. Actually we have two pairs, so it will also come under the category of trapezium as well. So these kind of questions you can answer over here, that all parallelograms are trapezium. Yes. All trapezium are parallelogram. False. Okay. Then under parallelogram comes rectangle, rhombus. Rectangle is a parallelogram in which all angles are 90 degree. What is rectangle? Rectangle is a parallelogram in which all angles are 90 degree. What is a rhombus? A rhombus is a parallelogram in which all sides are equal. Okay. Also you can say rectangle is any quadrilateral where all the angles are 90 degree. If in any quadrilateral you have all the angles as 90 degree, it will be a rectangle. In any quadrilateral all the sides are equal, it will be a rhombus. Then under rectangle and rhombus comes square. A square is a rhombus as well as a rectangle. A square is a rhombus whose all angles are 90 degree. A square is a rectangle whose all sides are equal. Got it? And square also comes under kite as well, because in a square all sides are equal, so two pair of adjacent sides will definitely be equal. Okay. Similarly, rhombus also comes under kite. Rhombus also comes under kite as well. So this is a graph, this is a chart with which you can easily remember that which quadrilateral falls under which category, and the definitions you can easily remember for all of that. Okay, then comes, so these are the different shapes which I have told you. This is your trapezium, kite, this is your trapezium, kite, parallelogram, okay, then rectangle, this is your rhombus, and then this is your square. Got it? So these are your different quadrilaterals. After that, properties of parallelogram. So first important property of a parallelogram is the diagonal of a parallelogram divides it into two congruent triangles. So we can say triangle ADC is congruent to triangle CBA. Why? Because see, this angle is equal to this angle because of interior alternate angle. I know AD is parallel to BC. Then I can say this angle is equal to this angle because AB is parallel to CD. Both the pair of opposite sides are parallel, and then AC is the common side. So with this I can clearly say that both the triangles are congruent. Since both the triangles are congruent, this is the first property. So from here we get many other properties of the parallelogram. So first is opposite sides are equal. By CPCT I can say this side and this side is equal to each other, this side and this side is equal to each other. In a parallelogram, adjacent angles are supplementary. Adjacent angles are supplementary, that means angle A plus angle D will be equal to 180 degree, or angle A plus angle B will be 180 degree, angle B and angle C will be 180 degree, angle C plus angle D will be 180 degree. The reason is interior consecutive angles. Interior consecutive angles. Then opposite angles are equal. Opposite angles, how they are equal, beta? If these two triangles are congruent, clearly angle B is equal to angle D. Okay, same proof of the congruency of triangle by CPCT we are saying this. And diagonals bisect each other. So for diagonals bisect each other, what you will do, the proof we have already done under Umang series. So Umang series mein, if you will follow the session, you will get the proof for all these properties I have done one by one. So if ABCD is a parallelogram and O is the point of intersection, remember AO is equal to OC and OB is equal to OD. Got it? So this is the property. These are the properties of parallelogram. Remember, all these properties are followed. All these properties are followed by square, by rectangle, and by rhombus. By square, by rectangle, and by rhombus. Another thing is that this square, rectangle, rhombus, they will be having some extra properties. They will be having some extra properties as well. So the extra properties of square, or first let's talk about rectangle. So extra properties of rectangle, if I will talk about, other than the properties of parallelogram, other than the properties of parallelogram, the extra properties of rectangle is, remember, first thing, all angles are equal. All angles are equal because all angles are equal to 90 degree. Second thing, which is a very important property, that diagonals are equal in length. In parallelogram, the length of the diagonals are not necessarily equal. You can clearly see AC is looking greater than BD, right? But in rectangle, the diagonals are equal in length. So these are the extra properties. For rhombus, the extra properties are, one, according to the definition, all sides are equal. Second important thing is, see, in a rhombus, diagonals are not equal, not necessarily equal, but the thing is, diagonals bisect each other. Ab dekho, diagonals are bisecting each other in rectangle also, because diagonals bisecting each other is the property of parallelogram. So it is true for square, rectangle and rhombus, but the important thing is diagonals bisect each other at 90 degree. Diagonals are perpendicular to each other. Diagonals are perpendicular to each other. And as in the square, by first thing is all angles and all sides are equal. Then the square also falls under rectangle as well as rhombus. So I can clearly say, second property, length of diagonals are equal, which is a property of rectangle. And the third thing is diagonals bisect each other at 90 degree. So square follows property of all the special quadrilaterals. Diagonals bisect each other at 90 degree. Okay, we have done the proof for it. Minimum condition, whenever we have to prove any quadrilateral to be a rectangle or to be a square or to be a rhombus, to be a parallelogram, all of that we have done in detail in Umang series. Do watch out those videos for the detailed explanation. Since it is a revision session, we have to be quick in this part. Okay, after that comes your midpoint theorem. I have done the proof of midpoint theorem as well. Do watch that session. I am just explaining what the theorem says. So this theorem says that if I have a triangle ABC, and if I know that E and F are the midpoints of AB and AC, E is the midpoint of AB, F is the midpoint of AC. If it is the case, then the line joining midpoints of any two sides of a triangle, the line joining midpoints of any two sides of a triangle will be parallel to the third side. This will be parallel to the third side and half of it. This is your midpoint theorem. Very important theorem. Okay, this is your midpoint theorem, that EF is parallel to BC and EF will be half of BC. Now there exists the converse of midpoint theorem as well. Both the proofs are very similar. Once if one proof, if we are going in this order, converse means the proof is exactly the reverse one. Okay, so you can see both the proofs which I have done in the Umang series. Do check out those videos. The proof I have done in detail. Okay, so what does this midpoint theorem, converse of this midpoint theorem says? It says, suppose I know that E is the midpoint. Suppose I know E is the midpoint, and through E, if I draw a line parallel to this BC, if I draw a line through E parallel to BC, I can say for sure that this line E from E parallel to BC will intersect the third side AC at its midpoint. So F will be the midpoint. So I can clearly say if E is midpoint of AB. This is very important theorem. Converse also is used a lot. Whenever you have to prove that F is some point is a midpoint of any side, converse will be used. So if E is the midpoint of AB and EF is parallel to BC, then I can clearly say F is midpoint of AC. That is, AF is equal to FC. Okay, these are all the theorems and the concepts involved in this chapter. Now let's look at some questions. Okay, so before I move ahead, let me tell you all that those students who are feeling that you need some guidance for your final preparation, you are more than welcome to join Vedantu's Pro subscription. Okay, in which you will be having the features like unlimited classes. You can download the notes, doubts will be solved. Okay, many micro courses are there from which you can learn at any point of time, whenever you are feeling comfortable. Your time scheduling, everything is up to you. So to register for this, the link is mentioned in the description box of this video, as well as it will also be there in the pinned comment. It will be the pinned comment. So in that pinned comment, the link is also given. Just go there, apply the coupon code GPE Pro to get 20% off. I will tell you in more detail about this, but let's move ahead first now. So first question is this: the angles of a quadrilateral are in the ratio 3:5:9:13. Find all the angles of this quadrilateral. So if the ratio of the angle is given like this, I can say angles are 3x, 5x, 9x and 13x. And since they all are angles of a quadrilateral, their sum will be equal to 360 degrees. Okay, so 3 plus 5, 8, 8 plus 9, 17 plus 13, 30x is equal to 360. So x is equal to, divide the over there, x is equal to 12 degrees. So all the angles, 3x will be equal to 3 into 12, 36 degree. 5x is equal to 5 into 12, 60 degrees. 9x is equal to 9 into 12, 108 degrees. And 13x is equal to 13 into 12, which is equal to 132 degrees. Is it 100? Sorry, 136. Oh, sorry, not 132. I've written it wrong. 144 plus 12. So it will be 156. 156 degrees. Okay, so 36, 60, 108 and 156 degrees will be your angles. Okay, let's go for the next question. If the diagonals of a parallelogram are equal, then show that it is a rectangle. Ab dekho, in these questions you need to understand that it is given to you that the given parallelogram, the given diagram is of a parallelogram. So they have not told that, suppose if I assume a quadrilateral ABCD, A, B, C, D. So they have given me ABCD as a parallelogram. The only thing they have given is that the length of AC is equal to the length of BD. AC is equal to BD, and I need to prove now that it is a rectangle. I need to prove now that it is a rectangle. So what I will do, I will talk about two triangles. I will take two triangles. One is your triangle ABD. One is your triangle ABD, and the other triangle will be your triangle ACB. These two triangles, let's talk about these two triangles. So I can say now that, sir, in triangle ABD and ABD and triangle BAC, beta, first thing, listen very carefully, since it is a parallelogram, AD is equal to BC, right? Then I can say AB is the common side. And the question itself has given that the length of diagonals are equal. So I can say AC is equal to BD. So I can clearly say, sir, by SSS rule, triangle ABD is congruent to triangle BAC. And if they are congruent triangles, I can clearly say that angle DAB is equal to angle CBA. Angle DAB. So when I am talking about angle DAB, which angle I am talking about? I am talking about angle A, and angle CBA is your angle B. So from here we got to know that angle A is equal to angle B. First equation. Also, I know since ABCD is a parallelogram, angle A plus angle B must be equal to 180 degrees. Angle A and angle B must be equal to 180 degrees. Let's say angle A and angle B both are equal to x degrees. Let's say both are equal to x degrees. So x plus x is equal to 180. So from here you will get x is equal to 90 degrees. So in a parallelogram, if any one angle, in a parallelogram, if any one angle is 90 degree, automatically all angles will become 90. How? Understand. Like if I say any one angle, it is a parallelogram, any one angle is 90 degree. I know opposite angles are equal. So this angle will be 90. Adjacent angles are supplementary. So if it is 90, this will also be 90. If it is 90, this will also be 90. Automatically all became 90 degree. So if any one angle is 90 degree, automatically all angles are 90 degree. So I can say ABCD is a parallelogram in which all angles are 90 degree. That means ABCD is a rectangle. Okay, the minimum conditions which I have done in the Umang series videos, very important. Go through those sessions. I am telling you, your all the doubts related to the quadrilaterals topic will be done. Okay, next question. Question number 3 is, in a parallelogram ABCD, 2 points P and Q are taken on diagonal BD such that DP is equal to BQ. Okay, what they have given over here, that this line DP is equal to BQ. Okay, and ABCD is a parallelogram. Okay, show that triangle APD is congruent to triangle CQB. Okay, so let's talk about these two triangles. So I can say, sir, in triangle APD and triangle CQB, but the first thing I know that, sir, BQ is equal to DP. It is given. DP is equal to BQ. First thing given. Right? Then I can say that, sir, this angle over here will be equal to this angle. Angle QBC is equal to angle PDA. Why? The reason is, beta, since ABCD is a parallelogram, AD and BC are parallel sides. BC is a transversal, so it is forming a interior alternate angles, right? And at the end, since I know ABCD is a parallelogram, opposite sides of a parallelogram are equal, so AD is equal to BC because ABCD is a parallelogram, or you can say opposite sides of a parallelogram, right? So which rule it is? Side, angle, side. So by side, angle, side rule, by SAS rule, I can say triangle APD is congruent to triangle CQP. First part done. Second thing they are asking, AP is equal to CQ. अब देखो बेटा, if these two triangles are similar, I can clearly say by CPCT that AP is equal to CQ. Chalo, second part is also done. Simple. Got it? Similarly, third one is exactly equal, exactly similar to that only. What is the third one saying? Third one is saying that prove triangle AQB, and triangle CPD are similar. So in triangle AQB and triangle CPD, where is AQB? AQB, I am talking about this triangle. And CPD, I am talking about this triangle. Okay, first thing beta, I know, sir, BQ is equal to DP given. BQ is equal to DP given. Then this angle QBA will be equal to this angle PDC. Again, because AB and CD are parallel, it is forming an interior alternate angle. Clearly you can see, let me show you on the diagram. Focus here clearly on the diagram. See, I know AB is the side, CD is the side of the parallelogram, they both are parallel. So BD is acting as a transversal. So angle ABQ is equal to angle CDP. These two angles will be equal to each other. These two angles both are equal to each other. So I can say angle ABQ is equal to angle CDP. And at the end, I can say, sir, the side AB is equal to the side CD. So here the reason is interior alternate angle. First part is given already, and I can say AB is equal to CD because again opposite sides of a parallelogram. Same thing we have told. So I can say by side angle side rule, triangle AQB is congruent to triangle CPD. Both the triangles are congruent. And third, fourth, AQ is equal to CP. So obviously AQ is equal to CP. Fourth, we can say by CPCT. Fourth part, we can easily say by CPCT, AQ is equal to CP. Right? So prove these two triangles congruent, got the second result. Prove these two triangles congruent, got the fourth result. Fifth one, they are saying prove that APCQ is a parallelogram. Beta dekho. Now, from the second result, I know that AP is equal to CQ. And from the fourth result, I know that AQ is equal to CP. Okay. From the second result and from the fourth result, I can clearly say APCQ is a quadrilateral. APCQ is a quadrilateral in which AP is equal to CQ and AQ is equal to CP. So both the pairs of opposite sides are parallel, are equal. So since both pair of opposite sides are equal, so if in a quadrilateral we have both the pair of opposite sides are equal, we can clearly say APCQ is a parallelogram. Okay, many students will feel ki sir, then it will be a rectangle, na? No. If in a quadrilateral both the pair of opposite sides are equal, it is a parallelogram. If it is a rectangle, remember in that case you have to prove that any one angle is also 90 degree. You have to prove that these angles are also 90 degree, which we cannot prove over here according to the data. So I will only say when in a quadrilateral both the pair of opposite sides are equal, it does not mean it is a rectangle, it means it is a parallelogram. Similarly, if in a quadrilateral all the sides are equal, it does not mean it is a square, it means it is a rhombus. It means it is a rhombus. To prove it a square, we need to prove that the angles inside that quadrilateral are also 90 degree. Got it? So this is the difference. Very important part over here. Many students make mistake in this part. Got it? Let's go for the next question now. Next question is this. What it is saying, ABC is a triangle right angled at C. Okay, so I think we have to draw the diagram over here. Let's draw the diagram. So let's say we have a triangle over here, right angled at C. So let's say it is your triangle ABC, right angle at C. A line through the midpoint M of hypotenuse AB. Midpoint of the hypotenuse AB. So M is the midpoint of the hypotenuse AB. Through that, a line drawn parallel to BC. So parallel to BC, we are drawing a line. These two are parallel to each other. Okay, parallel to BC, intersect AC at D. This point is what? D. Show that first one, D is the midpoint of AC. So beta, first one is very easy. Yeah, this is nothing but converse of midpoint theorem. We know M is midpoint of AB, and it is also given that DM is parallel to BC. So by converse of midpoint theorem, we can clearly say D is midpoint of AC. D is what? Midpoint of AC, or I can say AD is equal to CD. First part done. Next thing, MD is perpendicular to AC. Ab dekho, MD is perpendicular to AC. Again, very easy proof. How can I say that? Simple thing, sir. I can say angle ADM is equal to angle ACB. Both will be equal to 90 degree. What is the reason? The reason is, since DM and BC are parallel, this angle and this angle must be equal because of corresponding angle. So the reason here is corresponding angles. Done. One line proof it is. If you will understand the question and think about the diagram, once you have diagram in front of your eyes, the questions becomes very easy. Third one is prove that CM is equal to MA, and CM and MA both are equal to half of AB. So CM and MA, so C and M we need to join. So I have to prove that CM and MA both are equal, and I know since M is the midpoint, so we know that AM is equal to MB, both are equal to half of AB because M is the midpoint. So now I need to prove that CM and AM are equal to each other. So what we'll do, we'll talk about congruency of the triangle. Which two triangles? We will take two triangles which deals with these two sides, CM and AM. So I saw that in triangle AMD and triangle CMD. Okay, listen carefully. By first thing beta, I know that AD is equal to CD. Look over here. AD is equal to CD. Okay. Second thing beta, I know that angle ADM is equal to angle CDM. By if this angle is 90, this will also be 90 na? By linear pair. Both are equal to 90 degrees. Yes. And the third thing, DM is equal to DM, common side. So I can clearly say, sir, by side angle side rule, triangle AMD is congruent to triangle CMD, and if they are congruent, by CPCT, corresponding parts of congruent triangle, we can say AM is equal to CM. AM is equal to CM, and since AM was equal to half of AB, CM also will be equal to half of AB. Right? This is my third proof. You can clearly see one line proof. All are one line proof, nothing else. Okay, beta. Chalo, let's go for the next question now. Next question is this. In the given figure, ABCD is a square and angle PQR is equal to 90 degree. ABCD is given a square, PQR is 90 degree. Then they have given PB is equal to QC is equal to DR. PB, QC, DR. Look at the diagram carefully. PB, QC and DR all are given equal to each other. Right? If you cannot see this side PB, QC and DR all are given to equal to each other. Prove that QB is equal to RC. Okay, I have to prove that QB, where is QB? QB is over here and RC is over here. That I need to prove they are equal. Okay, now focus. Yeah, we know ABCD is a square. We know ABCD is a square, so in which all the sides are equal. So I can clearly say that sir, BC and CD will be equal to each other. Why I am talking about BC and CD? Because BC can be written as BQ plus QC is equal to CD can be written as CR plus DR. Right beta? Ab I know कि sir they have clearly given in the question that QC and DR are equal to each other, so they both will get cancelled. Both are same na? Both are same, so both got cancelled. So we are left with BQ is equal to CR or QB is equal to RC. Done, 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 done. First part done, right? So I have taken BC equal to CD, and BC I have written as BQ plus CQ, and CD I have written as CR plus DR. Then I saw that DR and CQ are equal to each other, cancelled both, so BQ is equal to CR. Okay. Second thing they are saying, prove that PQ is equal to QR. A PQ and QR, if I need to prove, what I will do beta, I will talk about these two triangles. Which triangles? Listen carefully. I will talk about these two triangles. Okay, so I can say for the second part, in triangle, which two triangles I am talking about? In triangle QCR and triangle QCR and triangle PBQ. First thing beta, we know PB is equal to CQ. PB is equal to CQ given in the question. Second thing beta, I know angle B is equal to angle C. Both are equal to 90 degree. This angle is 90 B. This angle at C is also 90 degree. Yes, and from the result from the first one, we know BQ is equal to CR. Let me use a high part pen. So this is 90, this is 90, and from the result one, we can clearly say BQ is equal to CR. So I'm saying BQ is equal to CR. So which rule it is beta? Again we have used side angle side rule. So I can clearly say, sir, by side angle side rule, triangle QCR is congruent to triangle PBQ, and if both of them are congruent, I can clearly say, sir, PQ is equal to QR by CPCT. By CPCT. Got it? This is how you have done this question. Clear? So we have proved PQ equal to QR by taking about the congruency. So remember, triangles chapter is very important. Even in quadrilateral also you are using the concept of triangles. Now we have got PQ is equal to QR. We have got PQ equal to QR. I need to prove that angle QPR, this angle is 45 degree. So what I'll say that, sir, if I look at triangle PQR, so I will say, sir, in triangle PQR, we know PQ is equal to QR. It is an isosceles triangle. So the side angle opposite to them will also be equal. So opposite to QR, we have angle QPR, and opposite to, sorry, QPQ and PQ and QR, not QC. PQ is equal to QR. Here also written na PQ equal to QR. Yes. So since PQ and QR are equal, opposite to QR we have angle QPR, opposite to PQ we have angle QRP. Both are equal. Let's say both are equal to X degrees. Okay. This is also X. This is also X. Now let's use angle sum property. So I can say in triangle PQR, if I use angle sum property, in triangle PQR, if I use angle sum property, so X plus angle PQR is given as 90 degree. 90 degree it is given is equal to 180 degree. So from here you have got 2x is equal to 90 degree. So x is equal to 45 degree. That means your angle QPR as well as angle QRP both will be equal to 45 degrees. Right? So this is how, using the properties of the quadrilaterals as well as what you have studied in your topic lines and angles as well as what you have studied in your topic triangles, all the knowledge will be used in quadrilateral. So geometry is all related. It's not like when you are reading quadrilateral there is no relation with the previous chapters. Everything is related. So make sure you go through each and every chapter. If you have not done lines and angles, you will face difficulty in triangles. If you have not done triangles, you will face difficulty in quadrilateral. So all the geometry sessions should be done one by one. Got it, beta? So this is how you will do the solution. Once again, I am telling you that those who want to register for Vedantu's Pro subscription, the link is mentioned in the description box of this video. The link, the coupon code which you can use is GPE Pro, which will give you 20% off. Okay, so this will be your price after applying the coupon code GPE Pro. Let me tell you, this is for 1 month, this is for 3 months, and these prices are inclusive of all the subjects: maths, physics, chemistry, biology, SST, English. So if you will see per subject, it is way cheaper than any home tuitions you are going. So very good thing right now. If you need the guidance, if you think you need guidance, you can join Vedantu's anytime. All of you are more than welcome. Got it, beta? So this is all from my side in this session. I hope all of you went through this questions. Do solve these questions once again on your own. And if you are not followed the Umang series, do follow the Umang series in which I have done all the proofs, all the theorems in detail. Because in one short video, it is very difficult to complete all the theorems, their proofs, and all their proof in one session. So it becomes difficult. That is why I'm telling you the Umang series quadrilateral topic. Do search for that Umang series quadrilateral. Everything you will get over there. So thank you so much, bachcho. Please don't forget to like the video before you leave. Share the video with your friends and subscribe to the channel if you are new here. Thank you so much. I'll see you soon. Bye bye. Sayonara. Khuda Hafiz to all of you. Bye bye.